Hi everyone, I'm back. I'm here to try to solve LeetCode number 131 palindrome partitioning. Let me read the problem for you. Given a string S, partition S such that every substring of the partition is a palindrome. Return all possible palindrome partitionings of S. As we know, a palindrome is a number that or string. When you look at it forwards and backwards, it's the same. So in this problem, we're trying to find, given a string, all possible partitions of the string that form palindromes. Obviously, we have the string A, and B. If you break the string down into its own individual characters, such as A, and B, each one is obviously a palindrome. A looking forward is the same as A looking backwards. Then you have this set right here of A, and B. A looking forwards and backwards is the same as we already established that B as a single character is a palindrome. So basically, given a string, you want to return all possible palindrome partitionings of S, all possible. So this is a rather challenging problem, and I struggled with it for a bit. I always like to write down the constraints before I start any problem. One is less than or equal to S dot length, which is less than or equal to 16. We also have that S contains only lowercase English letters. And this is I'm just going to say it, this is a backtracking problem. I'll be honest with you, I've always struggled with backtracking problems, and it's one of the hardest types of problems for me to understand. So I had to take a look at two solutions that made sense to me, one from LeetCode as well as one solution from ChatGPT. And I'm going to try to do both approaches in this video right now. So let's take a look at the approach that is given to you, that you can find on YouTube, that the LeetCode uses. What's the algorithm? So we define an isPalid function that is in the class solution that will check whether a string is a partition, right? Then you have to define within the partition function a result, and define lists within the lists. Define within the partition function lists result and part. Then you define an inner function dfs I that will be the backtracking function. Check within DFS if you can append the current part to the result. Then you will loop through the string s and check if you've found any palindromes palindromes using a new variable j. If you've found a palindrome, append it to the part, which is what you have right now. Call DFS again. And this is a critical part. Do part.pop. You need to pop off the palindromes that you found, so that because you only have one list part, you have to use part over and over again, so you always need to do the pop operation. And then lastly, outside of the inner function, call DFS with start equals with index 0, return the result. Okay, this is a lot, but let's try doing it. Def is palid self s l r if, not if, while L is less than R, if S L does not equal S, R, return false. You have to update the pointers now. L, R equals L plus 1, R minus 1. Brilliant. And then return true. That's the isPalid function. Okay. Let's define. Okay, so now we're done with this step. So we're going to define res and part equals two lists right here. Done with this part right here. Define the inner function def dfs I. That will be using the backtracking function. So the thing we need to do is check if we can append part to res right now. So let's do it. N equals len s. If I is greater than or equal to len s, then you would do res.append part, and you make a copy of the part right here with this notation, and you return it. So that's this part. There's this two part. And then what you do is, this is where it gets kind of tricky. And then you have to do a for loop for j in range I to n, where j is a new variable. Let's check if we found a palindrome. If self.isPalid of s, I, and j, if that's a palindrome, then what do? You found a palindrome, right? So you append it to part.append S I J plus 1. Now you call DFS J plus 1 to invoke the backtracking, and you do part.pop. That, I believe, is a DFS function. And that's all these steps right here. And so lastly, you would do DFS 0, and then you do return res. I believe this is the answer. And this is the answer that was given in the way that LeetCode did it. Let me check it. Okay, it's good. Fantastic. I'm not gonna for this problem, I'm just going to I didn't really memorize it this time, but I'm just gonna paste it right here for you all from my notes, that the time complexity is n times 2 to the n, where the worst case is 2 to the n possible palindrome partitioning, and you're check for palindrome partitions, and you're checking that each palindrome is valid with an O of n time algorithm. So that's why the time complexity is n times 2 to the n. Let me say that one more time. In the worst case scenario, you have 2 to the n number of palindrome partitions, and to check if each partition is a palindrome, you have O to the n, and the space complexity is also n times 2 to the n. So this is the LeetCode algorithm and how he did it. So now let me show you the way that you do it if you try looking for this problem via ChatGPT. Give me 1 second to erase all, not erase all this, but actually let me move this right here. Let me do it this way. This is the LeetCode approach. Okay, so I think we are done with the LeetCode approach, and I'm gonna just comment all this out right here. Okay. Now let me try the this is from ChatGPT. Define an isPalid inner function that checks if a string is a valid palindrome. Give me 1 second. Okay, so then you define a DFS function with a start and path. That's where the DFS inner function. You have two inner functions right here. The inner function with the start and the path. Then you check whether the current path is good, and you can append it to the result. And then you do a loop from the loop of the end values. So that's going to be from start plus 1 to len of s plus 1. Check if you have valid palindromes. call DFS again to begin the recursion. Let me try implementing this. Okay, so def is palid s. So return s equals s. If s equals s colon -1, then you know it's a valid palindrome, because the string, looking at it from the forward direction, is the same as looking at the string from the backwards direction. Then you define a function dfs with a start and a path. And so let me do n equals len of s. If start equals to n, then let's do an append this to the result dot append, and we haven't defined result yet, but I'm going to result dot append path, and then I'm going to return. Then you check, you do a for loop for end in start +1 to n +1. You check if is palid s start end. If you found a palindrome, then you call DFS again with end, and then you do path plus, you have to double quote it, you have to convert the string to a list and then append it to path. So you do s from start to end, and then outside of both inner functions you define result, right, that we were just going to talking about. You call DFS start with 0 and an empty list, and you return the result. Let me run this and see if this is it. If, oh, whoops, this is a wrong syntax. Memory limit exceeded. Okay, let me fix this. Right here, I forgot the range. There we go. Let me see if I submit it and it works. Okay, and so this one is a little different time complexity than the other one. So this is an O of time complexity. It's O of n times n squared. In the worst case, which makes it an n cubed, because the worst case is you have to make n squared number of recursive calls, and you have n number of characters that you're checking if it's a valid palindrome or not. You have, so that's why it's n squared, right? N squared number of recursive calls, and you have n times where you're checking if the string is a palindrome, potentially in the worst case, and the space complexity is like the other one, n times 2 to the n. This was, I have to say, a very, very challenging problem for me. I don't know why, but it was very, very challenging. So it was good for me to go over it. Yeah, so I think if I keep practicing, I'll definitely get better at this. So I just have to keep doing it. Thank you very much, and I'll see you at the next one.